This is the lesson for Chapter 5, Section 3, titled Solving Systems of Linear Equations by Elimination, Day number 1. So let's take a look at our first problem. And it looks like a tough problem the way we had solved before, because we have to get a variable by itself and we'd have to substitute into an equation with coefficients in front of the x and the y. So in this case, this one's a great one for what we call elimination. Elimination means that we want to eliminate one of the variables that we've got, and we're going to eliminate by adding or subtracting the equations together. Now we can only do this if we have the same coefficient but opposite sign. Like here we have negative 5x and positive 5x. And so then we could add these two equations together, and the 5x's, the negative 5x would cancel out the positive 5x, leaving us only with y's. Now we can also only do this if everything's lined up. Like here the x's are lined up, the y's are lined up, equal signs and constants are all lined up. So I could go ahead and add these two equations together. The x's will cancel out, leaving me with 3y. I got 3y because 2y and 1y make 3y. 13 plus negative 1 is going to end up giving us 12. And so I divide by 3, and I have y is 4. So now I can go ahead and substitute back in. So elimination works really well to find the first variable, but then once you get to this point, you still have to substitute. So I'm going to put it in for this second equation. So I've got 5x plus y, which is now 4. 4 went in for this y, equals negative 1. So I need to subtract the 4 from all sides, leaving me with 5x equals negative 5, and then I can divide by 5, and I'd have my answer. X is negative 1. So what I've got is negative 1 comma 4. Let's see if it's correct. So to check, we're going to go ahead and substitute into the other equation. And so I've got this equation, negative 5x. So it's negative 5 times negative 1, because that's what x is, plus 2y. So y is 4. And then this all equals 13. So let's see if we did it right. This makes 5 plus 8 equals 13. Yes, 13 equals 13. So once you get an equality like this, you know you've done it right. And then you can box your answers. So negative 1 comma 4. So moving on to the next problem here. Make this a little more clear. So negative 1 comma 4. So moving on to the next one, we've got a problem in which if we tried to add these equations, the y's would not cancel. They'd actually make 8y. So what we have to do is modify one of the equations. So I'm going to modify it by multiplying it by a negative 1. Every term needs to be multiplied by negative 1 if I'm going to do that, to keep everything in balance. And what it'll do is it'll switch all the signs of that term that I went ahead, or that equation that I went ahead and multiplied by. So now we can get those y's to cancel. So I'm left with 4x, the y's cancel out, and this all equals negative 8. So when I divide by 4, I get x equals negative 2. So again, you can see how much quicker it is than substitution, at least to find the first variable. But you still have to substitute in to find the other variable. So I'm going to choose to substitute negative 2 into that first equation prior to us modifying it. So 3 times negative 2 plus 4y equals negative 6. So 3 and negative 2 multiply to make a negative 6, plus 4y equals negative 6. And when you have the same term on both sides of the equal sign, they're going to cancel. You can see that when I do the opposite operation there. See how those 6's will end up canceling, leaving us with 4y equals 0. So the only number that multiplies by 4 to make 0 is 0. So y is 0. And so our point is going to end up being negative 2 comma 0. Let's check to see if it's right. So let's plug it in for that other equation. 7 times negative 2 plus 4 plus times 0 equals negative 14. And so now I've got 7 times negative 2 makes negative 14 plus 0 equals negative 14. So the two negative 14s equal each other, so I know I did it correctly. So this is our solution. And so again, what that solution is where the two lines cross. This is where those two lines, what they share in common. Moving on to the next problem. Here if I tried to add the equations together, I would not get x's or y's to cancel. I can't just multiply by a negative 1. I need to actually multiply by a number. So I got a choice. I can multiply by either negative 2 to cancel out the x's, or negative 3 to cancel out the y's. I'm going to choose multiplying by negative 2. Just seems like a smaller number to deal with, so I get negative 6x minus 2y is going to equal negative 22. So when I go ahead and add this together, I get the x's to cancel, and I'm left with 1y equals 2. So I got the equation just like that, or at least the value of y. So I'm going to substitute back into that top equation. 3x plus 2 equals 11. So I could subtract the 2 from all sides. So I'm left with 3x equals 9. Divide by 3, and we'll have our answer. X is 3. So let's check and see if it's right. So far this is what we think it is, 3 comma 2. So I'm going to take that equation, substitute into the other equation to see if I get an equality. 6 times 3 plus 3 times 2 equals 24. So this makes 18, this makes 6, and those two numbers do equal 24 when I add them together. So I do get an equality, and so I know the answer is correct. So the next problem, same sort of thing. Here I could multiply that bottom equation by 4, and that will make it a negative 4x to cancel out the x terms. So I multiply every number there by 4, and I end up with a new equation, negative 4x minus 8y equals 32. I'm going to just rewrite this top equation down below so I can see a little bit better, make sure I'm making the addition and subtraction, or at least doing that correctly. So I'll add these two equations together, and I end up canceling out the x's. I get negative 13y equals, and this gives me 51. Actually, no, I got to subtract here. So I end up having to borrow, and that ends up giving me a 3, and this is a 1, so 13. So 13 equals negative 13y. So when I divide by negative 13, you can see how you're getting y is negative 1. So I go ahead and substitute back in, and I'll put it into this equation before I modified it. Negative x minus 2 times negative 1 equals 8. So that's negative x equals, actually not equals, but plus 2, because the negative and the negative cancel each other out, equals 8. So I subtract the 2 from all sides. That leaves me with x equals, or actually the negative x equals positive 6. So when I multiply by a negative 1, all numbers there, it's going to end up being x equals negative 6. So I'm going to go ahead and write my ordered pair down, negative 6 comma negative 1. And again, if you mess up on one of the signs, you'll see if you did it wrong if you do the check. So let's do the check. So 4x, so 4 times negative 6, and then minus 5 times by negative 1 equals negative 19. And so I go ahead and multiply. It makes negative 24 plus 5, because negative 5 times negative 1 makes a positive 5, should equal negative 19. Let's see if we did it right. So when I subtract these two numbers, I do get negative 19. So since the numbers do agree, that means I did the problem correctly. So negative 6, negative 1 is the solution. Those are the types of problems you're going to see on tonight's assignment. Good luck.